Hi, my name is John Saville, and in this presentation I want to kind of update an infrastructure as a service in Azure overview that I previously recorded a couple of years ago. Technology changes, so I thought now would be a good time to create a new version for 2017. So before I talk about IaaS specifically, it's good to quickly review what are the types of service we can actually have. Now, I don't usually PowerPoint, but this is actually a good PowerPoint slide. So this is really the layers we have when I think about any kind of service. So on premises, I manage the network fabric, the storage, the servers, the hypervisor, and then I create virtual machines. Inside that virtual machine, I manage the operating system. I get complete choice in what I do. I also have full responsibility. I have to patch it. I worry about anti-malware. I worry about backing it up. I worry about applying configuration. I then deploy various runtimes, middlewares. I'm responsible for the applications and the data. Now, when I get to as a service, infrastructure as a service, or VMs in the cloud, here the vendor is now managing the physical fabric, the storage, the compute, the networking, and the hypervisor. What I get is a virtual machine. Now, within that virtual machine, I'm still the boss. I pick the operating system. Now, it has to conform to the capability set of Azure, but that's very broad. So I get to pick the operating system. That means I'm responsible for the operating system. I'm still responsible for patching, the anti-malware, the backing it up, the applying configuration. Now, when I think about Azure, there are things to help you. Yes, you're responsible. It doesn't mean you're on your own. For example, initial configuration. There is a VM agent. There are extensions. I can use PowerShell DSE. I can use Chef. I can use Puppet to apply configuration. For the anti-malware, again, there's extensions. I can use Windows Defender. There are third-party anti-malware solutions that can hook in. Backup. I can use Azure Backup. Again, through the VM agent, I can use that extension and automatically back it up on a schedule. Even the patching. There's capabilities built in. There's Operations Management Suite. There are things to help me. But I'm responsible for that. I pick the middleware, the runtime. I have to update those things. I manage my app, my data. So I have full control. I have full responsibility. A bit too quick. Then there's platform as a service. So platform as a service, now it's a different world. I don't see a virtual machine. Yes, there are still virtual machines behind the scenes. What I get is a service. I get Azure App Services. I can create web apps, mobile apps, SDK apps, where I just super focus on the functionality I want. Everything else is just provided for me. There's Service Fabric, where I can use the actor model to very easily create synchronized replication, multiple instances that quickly take over if one fails. I can use containers, and some of these are kind of a hybrid, but my focus becomes the app. I don't worry about the other fabric stuff, that's just done for me. I don't worry about patching operating systems or middleware or runtimes. Then at the end, there's software as a service. Software as a service, I don't manage anything. Office 365 will be a good example of this. I'm not patching SharePoint, I'm not patching Exchange. I get that service, it's backed up for me, it's highly available. I might do basic administration. I say, well, this user gets this feature, etc., XYZ, but I'm not actually managing the service, it's just provided for me. Now, I'm an infrastructure guy, but wherever possible, you want to stay as far to this side as you can. Hey, I need to implement some new service. Is it available as SaaS? Great, use that. Okay, it's not. I'm creating a custom application. Well, I'm creating it from scratch. Let's focus on a PaaS model. Can I use Azure App Services and a web app? Can I use containers? Can I use Service Fabric? Is it an Azure function? It's just a piece of code that gets triggered from something being put on a queue, some webhook. Okay, I can't do that. Maybe it's a legacy application. Maybe I need more control of the operating system. Well, then I get into infrastructure as a service. Also very useful if I think about migrating workloads from on-prem to Azure, I can pretty much lift and shift. Even if I'm running VMware or physical on premises, I can replicate everything in the OS and above into Azure and then just fail over and now run that in the Azure Fabric. So the types of Azure service. Now, when I think about Azure, it's really made up of regions. A region is not a data center. A region could be one data center, it could be 16 data centers. Today, they're really invisible to you. I pick a region I want to deploy to. Now, at a high level, I have a subscription that entitles me to deploy services within certain regions. I can pretty much deploy to any region. There are certain regions that are geo-fenced. For example, China, Australia, some of the others. Those I have to have a company in that location to use them. But most of the other ones, hey, I can create services in Europe and America. I can create ones in Asia, for example, all within a single subscription. Often you'll see there's at least 2 regions in any geopolitical boundary. This is because for some types of service, there's an automatic replication enabled. For example, at a storage account level, if I was using a block blob, maybe an append blob, maybe certain types of table, I just wanted it to replicate between regions, it can do that for me. And it pairs the regions kind of opposite ends of that country, east, west, north, south, as far as possible. So if there was some problem, an earthquake, a flood, it's unlikely to take down both copies of your data that hundreds of miles apart. Or if it did take them both down, we probably don't care anymore. We have bigger problems. So I have all these regions available to me when I go and create my services. So within a region, there's one or more data centers. And so within those data centers, there's basically something called stamps. When Azure deploys new hardware, they deploy it in something called a stamp. It's generally about 1,000 blades at a time, maybe 20 racks. They're all the same hardware. There are compute stamps and there are storage stamps. And we'll talk more about storage a bit later on. So those compute stamps, they're all the same hardware. You might hear it called a scale unit or a cluster. It's not Windows clustering, totally different. But I can think about is deploying lots of racks, and then within a certain blade, I want to create a virtual machine. So the Azure Resource Manager, the Fabric Manager, picks a certain data center in the region I selected. It picks a rack, picks a node, and my virtual machine gets created. Now when I create virtual machines, there's a lot of different types. I can't custom create a VM. I can't say I want 3 cores and 1 gig of memory. There are series of virtual machines and sizes. And the series have different characteristics. Maybe some are more CPU centric, some are more memory centric, some are more storage focused, some have graphical capabilities, NVIDIA CUDA cards. Some have massive amounts of compute. I get to pick that. And what happens is, I'm going to show those in a second, but my virtual machine gets provisioned on a certain node. Something happens to that node, it would get healed at a fabric level and deployed to a different node. But there's also this thing called Azure Storage. And anything I write to Azure Storage is replicated 3 times. So at minimum, a page blob is used to actually store my OS disk. So this is my OS. It's got read-write caching by default. Now, if I gave this talk 6 months ago, I would have talked about storage accounts. I would have said we create a storage account. In the storage account, a page blob is created. The page blob contains the VHD. And I have to be very careful about how many VHDs I create in a storage account, because there's an IOPS limit for the storage account. If I put too many, I'll then hit constraints and it will throttle my performance. We don't worry about that anymore. We have managed disks. With managed disks, I don't see storage accounts anymore. The disk becomes a first-class object in Azure Resource Manager. I can do role-based access control on it. So with managed disk, yes, there is still a storage account behind the scenes. I don't see it. What I say is, create me a VM, use a managed disk. I want it to be of this certain tier, go. I don't see the storage account, I don't worry about the IOPS, it's just all automatically for me, it's managed for me. So I have this OS disk, and there's 3 copies of that data. Additionally, on the host itself, there is some local storage. And what also happens is, a VHD file gets created on this local drive. Now this by default is the D drive, temporary storage. There's 3 copies of this. This is stored on a storage stamp, it's highly resilient, those 3 copies of data are spread over 3 different racks within that stamp. That's durable. This is a disk or a couple of disks inside a node. If that node crashed, I lose the content. So the D drive is named temporary storage. There's a file at the root of the folder that says data loss warning, you're going to lose stuff. It's used for the page file by default. I could use it as a scratch drive. I don't put anything I care about on there. I would not store my data on there because if anything happened, if I resized the VM, if I deprovisioned it and shut it down, I'd lose that content. So think of the D drive just as temporary scratch storage. Now when we think about the series available, there's an A series virtual machine. This is really how IaaS started. With the A series, this is a hard disk drive. So it has certain performance characteristics. For all of the others, so the D, F, G, N, etc., it's an SSD. It's still not durable. I can still lose the content, but it's higher performant. So if it was a SQL server, I might use that for my tempdb. I could use it for buffer extension pool. So there's capabilities I can do with a faster temporary storage. I don't need it to be durable, I just want a faster temporary store. Now when I think about those options, there are a number of different sizes available. So I'm not going to go through all of these sizes. But you can see there's general purpose, there's compute optimized, there's memory optimized, storage optimized, there's ones with GPUs, there's high performance. Some of them have RDMA network adapters in them. If I just looked at general purpose, so this shows me, so there's sometimes you'll see a V2. A V2 is over time, they deploy newer versions of the hardware to a stamp. Well, that newer hardware probably has better processors, so higher performance. I, as a customer, don't want to one day deploy a VM and it's on an older stamp, so I get a certain performance. Then the next day I deploy another same size VM, but it happens to get deployed to a newer stamp and it's 30% faster. Now you might say, well, that's a great thing, I get extra performance, but I've lost my consistency. When I'm talking about planning what is my performance requirements, when I'm meeting those requirements, I don't like variability. And so the reason there is a V2 is when there are newer network compute stamps deployed, I get to pick. Hey, I want to maintain my existing performance, I won't pick the V2. I want to get the maximum performance available to me, give me the V2. And it's actually measured in Azure Compute Units. And you'll see often at the start of that previous page, it talked about Azure Compute Units, and it will show you the score for all of the different types of virtual machine. But I can see here a DS V2, I can get one with 1 core, 2 cores, 4, 8, 16. The amount of memory varies, the amount of temporary storage, how many data disks I can attach, the amount of storage IOPS, the amount of network performance, the amount of network adapters I can actually connect. So that varies depending on the size of the virtual machine. I see there's the regular D series, there's the AV2, the regular A series. So I pick the ones I want. If I go to compute optimized, for example, and I can see the F series. I see memory optimized, I get the M series. 128 cores, 2 terabytes of memory. So some really massive virtual machines available to me. And that brings me on to an interesting point. So I have all these different types of virtual machine. So there's a pricing calculator. Now I'm not going to go into the detail of this, but I can add various items. So I'm going to go and add compute. And for a standard VM, this is saying a D1, it's 14 cents an hour. Now I actually get billed on a per minute basis. I get billed for the time it's provisioned on the Azure Fabric. So it's either running or I just stopped it from within the VM, but I didn't shut it down at the fabric level, which means I still pay for it. So it's very important to stop paying for things to actually deprovision. I stop it from the portal, I stop it from PowerShell or the CLI, REST API. I have it scheduled for an Azure automation, but make sure you deprovision it, that's when you stop paying. If I just do a shutdown within the OS itself, it's still got a spot reserved on the fabric, I'm still paying for it. So here I can see Windows, rough cost $100. If I change it to Linux, it's now only $57. Why is it cheaper? Well, with Windows, it includes the Windows license. I don't have to bring my own license. I can. There is the Azure Hybrid Use benefit that enables me, providing I have sort of software assurance, I can sign up for Azure Hybrid Use benefit, I can use my data center licenses, my standard licenses, and bring them to Azure. Then I start paying kind of the Linux price for those virtual machines. But there's other things I can do. I could say, I want SQL Server. Well, now the price has gone up substantially. But it's leasing me the SQL license as well. So if I had a project that was going to run for 2 weeks or a month, I don't want to buy a whole copy of SQL Server. Hey, I'll lease it here. And then I'll delete it and I'll stop paying. Now if I was going to run it all year, 24/7, it's probably cheaper to bring your own SQL license, and you can do that. But it's all about choice. Speaking of choice, so there's that D1. Now if we go and look around, let's say a G5, 32 cores, half a terabyte of RAM. A bargain at $7,000 a month. Now you would say that, I don't want that. That's way too big. I'm not spending $7,000 a month. Shift how you think about resources when we think of the cloud. On premises, I purchase a piece of hardware. When I purchase that hardware, I'm very careful. It's a big spend. I think about, well, what do I need the hardware to do today? What do I need it to do for the next 3 or 4 years? And I have to size it accordingly. The cloud, I don't. The cloud, I can make a mistake. I start up the wrong size, I shut it down, I spent 3 minutes of compute. Now think of this G5. I had a customer, and they had this workload that ran once a month. It took 2 to 3 days. If it failed, they had to restart the whole thing. They had this big, powerful server sitting there just to run this job once a month. Well, they actually moved it to Azure. And they actually went ahead and used 5 of those. You say, wow, 35 grand. Well, the big deal is, when I used those 5, it only actually took 2 hours. So they went from a process that took multiple days to a process that took 2 hours and cost them $100 a month. I can do that. I can just start them when I need it and then deprovision them from the Azure Fabric. It doesn't lose its state. I still got the storage there. I'm still paying for the storage, but that's generally kind of pennies compared to other things. I can use resources in many different ways. I have access to this massive amount of resource when I want it. That's why when I think about cost, from on-premises to Azure, I have to think very differently. On-premises, it's there all the time. In Azure, I will scale. I will absolutely stop and start VMs based on when they're needed. If I had a 10-node IaaS farm, when I only need 3 nodes, I'll shut down the other 7. I'll stop paying for them. So pricing works very differently. This is why Azure is a great DR solution. I only really start paying the big bucks if I fail over, which hopefully we never do. So just important to really understand how that pricing really does differ. So I have all of these compute options. I pick the one based on the CPU I need, the memory I need, amount of data disk, network performance. I have all those different ones. I pick it, I can change it. There's just a reboot to do that. Now on the storage side, I mentioned the OS disk and this temporary drive. I can also add additional data drives. How many I can add really depends on the size of the VM. So these would be data drives. I can control, is it read-write caching, is it just read caching, is it no caching? Probably no caching for a database, etc. Recently this changed, these can be up to 4 terabytes in size. If you look at page blobs today, they can actually be 8 terabytes. So I wouldn't be surprised if this number keeps going up over time. On a standard managed disk, it can be 500 IOPS. Now that's a maximum. It's not a guarantee. I will get up to 500 IOPS. So what if I need more than 4 terabytes or more than 500 IOPS? Well, I can add multiple data disks, and then within the operating system, I could use storage spaces if it was Windows. I could just use striping if it was Linux. So I'd aggregate them together. I'd get the aggregated storage size and the performance. But there was another option. In addition to the standard storage, there's something called Azure Premium Storage. It's still replicated 3 times. I still can do managed disks, so I can do managed disk standard or premium. But here these disks, they can still be up to 4 terabytes in size, but I can actually get a higher number of IOPS. I think it's 7,500 IOPS or 7,300 IOPS. We can check that. So if we look at the site, if I go to my managed disks, we can see for premium managed disks, there's a 4 terabyte, 7,500 IOPS. So I can actually go up to 7,500 IOPS. So there's a big difference here. Standard storage, this is a maximum, not guaranteed. Premium storage, this is guaranteed. I will get 7,500 IOPS. There were changes made in the connectivity. There will actually be a smaller temporary drive that's partly used for caching purposes. The actual size is linked to the performance. So when I used a managed disk, you will see that the disk size directly correlates to the IOPS. So the bigger the disk, the higher the number of IOPS I get. So today I can go up to 4 terabytes, is the biggest, that's premium. With managed disks, I pay for the disk size. Again, a year ago, I talked about storage accounts, I talked about sparse storage, and I don't pay for the size of the disk, I pay for the amount of data I write to the disk. That is not the case with managed disks, premium or standard. I pay based on the size of the disk. So that's premium, standard, exactly the same. I pay based on the size of the disk. Again, this is still that 500 IOPS maximum. And they're always locally resilient storage, LRS. There's 3 copies locally. It does not include replication to another region. To be honest, for IaaS VMs, it's not a great solution anyway to have the storage doing the replication. It was asynchronous. There wasn't guaranteed that if I had multiple disks, they would replicate in sync with each other. So it's better to do replication either within the OS or at the application level. And there are solutions to help me do that. So when I need guaranteed IOPS, when I need higher number of IOPS, I use premium storage. To use premium storage, the virtual machine must be a something S series. So a DS, an FS, a GS. The S signifies, hey, I can use premium storage. You'll see a smaller temporary drive because it's using part of that for caching. So that's kind of the compute and the storage side. That's great. There's one other factor that really plays into sort of these servers and the storage. So I think about, I have racks. I talked about, hey, I deploy racks of servers. So I've got that rack. Let's say I've got 3 racks. And I want to deploy a service. Now I want to make sure it's highly resilient. If a node fails, if a rack fails, because a rack could be a point of failure. Top of rack switch could fail, the power could fail in that rack. And so when I deploy services, I want at least 2 instances deployed of any service. So what I want to happen is, well, one of them gets deployed on that rack. The next one gets deployed on this rack. If I deployed a third, go to this rack. But how do I tell Azure these are all the same service? Well, I create something called an availability set. By creating an availability set and putting VMs in that availability set, I'm telling Azure, hey, these are all doing the same thing. It's kind of an anti-affinity. Spread them over 3 fault domains. Now if I did 4th, a 5th, a 6th, it was just round robin between the same 3 racks. It's always 3 racks. If I had a different workload, I don't mix workloads in an availability set. Azure has no clue what's happening inside. It's just blindly going, okay, that rack, that rack, that rack. So if I mixed workloads, I could end up just with bad luck, all the IaaS on this rack, all the domain controllers on that rack, all the SQL on a different rack. So I would create a different availability set for every unique workload. Maybe that's my DCs. That would guarantee they get distributed around. And these are also used when there's planned maintenance done to the Azure Fabric itself. There's update domains. It'll only take down by default a 5th of my VMs. They don't get live migrated around. They get paused for less than a minute, but the others are still there to providing that availability. Why managed disks are really great here is that in the past I had this great resiliency for the compute, but they may have all been using the same storage stamp. And if the storage stamp had a problem, it wouldn't matter they were on different racks. If the storage goes, the VMs go. So when I have an availability set and I set it to actually understand and tie to managed disks, what it will do for each fault domain, it will actually tie to a different storage cluster. So the VHDs used by each fault domain are distributed actually over different storage clusters. So a storage cluster failure with managed disk would not take down VMs in different racks. So for the best availability, I want to use availability sets with managed disks. And that's a configuration on the availability set. Some regions only support 2 fault domains when I use this. There's a Microsoft article I wrote about it on ntfaq.com that tells you where to look those up. So that's availability, that's the storage side. Now, what is the next thing people care about? Well, it's the networking. And when I think about networking, at the outer layer, I have a subscription. And then I have a region. So they are the boundaries for a virtual network. A virtual network is constrained by the subscription and then a certain region. So a virtual network cannot span regions. I would need a virtual network in East US, one in West US, one in Europe, for example. So then I create my virtual network, and for my virtual network I get to pick the IP space, and I can configure the DNS configuration it will apply. So all of the VMs within virtual network get their IP configuration through DHCP. I can still have sort of static IP addresses because it's done as like a DHCP reservation. At the Azure Fabric level, I would say, well, make sure VM1 always gets this particular IP address. I would then break that space up into virtual subnets, and then VMs get created inside those virtual subnets. That's not strictly true. I actually create VM NICs. They're their own resource in Azure Resource Manager. The VM NIC gets bound to a subnet, and then the VM connects to the VM NIC. But to all intents and purposes, I'm putting VMs in virtual subnets. They can all talk to the internet outbound. Azure just provides NAT services, network address translation, so they can get to the internet. What about if I want to offer services to the internet? I need to listen on a public IP address, because these will all have a data center IP, a DIP. This is generally from RFC 1918, a 10 dot, a 172.16, a 192.168. They can talk to each other, but they're not internet routable IP addresses. No, you can bring a set of public IP addresses to use internally if you have a public IP space, but it still won't route out to the internet. You cannot bring your own public IPs to offer services to Azure. But if I owned a big class B or a C, I could bring a portion of it to Azure, but it still won't route over the internet. So I want to offer a service to the internet. Well, one option, sure, I can actually add a public IP to a virtual machine. Then every port, every bit of traffic would come in to that virtual machine. We don't generally want to do that. what we generally want to do is we'll create a software load balancer. The software load balancer has a front-end IP configuration. This could be a public IP address. Or it could be an internal IP address. I can have an internal load balancer. That would then receive traffic. I can then create a back-end set. So there's two things I can do. One is a load balance set. I could say we'll send traffic to that VM and that VM and that one. It will use probes to see, hey, are you actually there? Are you available? I can configure different levels of stickiness. And then the traffic comes in and it will distribute it. So I can do load balancing. I can also do NAT rules. I can say, well, traffic coming in on this port, always send it to VM3 on this port. It's a way to enable connectivity to back-end VMs through a shared public IP address. So those are my options for offering services out to the internet. Now what if I want to control communication? So there's a thing called network security groups. Network security groups enable me to create sets of rules. A rule is based on the 5-tuple set, source IP, destination IP, source port, destination port protocol. I can specify a direction and then an action, allow, deny, and a priority. So I create all of these rules. The destination IP and source IP can be based on a CIDR range. It could be an entire subnet. The port can be a range. So I could absolutely create an NSG. I apply it to the subnet. I can apply it to a VM as well, just gets harder to manage. So generally we apply it to a subnet. So I'm protecting this with a network security group. And this one. And this one. And my rule might say, well, this subnet, this can go ahead and talk to the internet. You're good. It can also talk to the middle tier. The middle tier can talk to the back end. But these guys cannot talk to the internet. This cannot talk directly front end to the back end. So I can craft all of these rules based on known IP space, based on if it's from the internet, is it from the Azure Load Balancer, and control all the traffic. I can also use virtual appliances. These are virtual machines. They can have multiple NICs connected to different subnets, and they're really just delivered by a third-party vendor to a best practice configuration. So I can do that as well. So it's great. I have networks. I have control of the traffic flow. I can offer services out to the internet. And if I don't like the software load balancer in Azure, again, I can use a virtual appliance. I can use a third party that really does the same thing. There's also sort of the Azure Web Application Gateway. It's a layer 7 balancer. It can do SSL termination and other great stuff. What about if I had multiple subscriptions? What if I had multiple virtual networks? How do I connect those? Well, a nice thing I can actually do, if I ended up having multiple virtual networks, but they're still within the same region, that's a requirement, I can do something called network peering. Network peering uses the Azure backbone to just link them together. I don't have to use a site-side VPN, I'm not doing anything else. I basically say, hey, connect these together. They can be different subscriptions, does not care, but they must be within the same region. If they were in different regions, well then I have to use something else. I could use a site-side VPN, I could connect them to the same ExpressRoute circuit. But if they're in the same region, network peering is great. It's just using that Azure backbone. So that kind of brings me on to the next point. Okay, so I've got Azure, and I've got my virtual network, but I've also got my on-premises stuff. How do I get them talking? So kind of the most basic option is, well, I can set up something called a site-to-site VPN. I have a gateway device in Azure. I have a gateway device on premises. It establishes a connection over the public internet, uses IPsec, and it connects them at an IP level. So it really just becomes an extension of my data center. It's called private peering. I'm linking this network space to this network space, and they can just talk. It's going over the internet. Now the speed, there's actually been a new gateways released for Azure. I can get good speeds now on this, over 1 gigabit per second. Latency, who knows? It's going via the internet. Every time the packet's going some different direction, maybe so there's some gateway in between, a router in between that's super busy, I don't get a consistent latency. And it is going over the public internet. And I can only link networks. So the next choice we have is I have the same idea. I have my virtual network. Once again, I have my on-premises. I can use ExpressRoute. There's really two flavors of ExpressRoute. They're doing the same thing. One of them is kind of an internet exchange point, like a fiber hotel. They have big redundant pipes into Azure. They drop a cable to your location. They do a cross connect. I now have a private connection to Azure. Doesn't encrypt, it's private connection. The other flavor of that is, well, imagine I had multiple locations. Maybe I have an MPLS today. Well, Azure can just become a node off of the MPLS. It's not going over the internet. Latency would be consistent. I can get up to 10 gigabits per second on the highest level of ExpressRoute. It gives me another benefit. Not only is the latency consistent, I can do higher speeds. Yes, I can do private peering. Private peering is linking this network space to this network space. I could have, with regular ExpressRoute, I can connect any virtual network in that geopolitical boundary. So anything in the US, anything in Europe, Asia. I can't cross those boundaries unless I do ExpressRoute Premium. ExpressRoute Premium, I now could link, hey, a region in in Europe, and one in the United States. So I could link those then. That's the premium add-on. But in addition to this, I can do something called public peering. There are other services in Azure. There's storage services. There's SQL services. There's backup. There's the DR traffic I'm using Azure Site Recovery sending in. There's tables, there's machine learning, and the list goes on. Ordinarily, those endpoints go over the internet. If I turn on public peering, that traffic will now go over my ExpressRoute connection instead. So it's just another option I have there. There's also something called Microsoft peering, though these are not generally used. I can do it for Office 365 traffic. There are some complications with the routing for public type services, and that's kind of an exception basis. These are the two you're commonly going to have. Private, I want to connect virtual networks. Public, hey, I want to use other services. And if I have connectivity requirements outside of my geopolitical boundary, then I can turn on ExpressRoute Premium, and then I can use really anything throughout the world. I hope that was useful. That was kind of updating, a very fast overview of lots of different technologies. Hope that helped. Appreciate you watching. Thank you very much.